what's a homogeneous mixture?
When it's homogeneous mixture is when it's the same throughout the whole thing, kind of like a glass of water.
No, glass of water is a salt and water. So in terms of what a mixture is.
Oh, you mean mixture? You're right. It's a mixture of two things, but it's the same thing throughout the whole thing.
So we gotta use our different vocabulary. So you want to say uniformed composition. Okay, in a homogeneous mixture, you have a uniform composition throughout. Okay, now a mixture is the combination of two or more different substances. What is specific about a mixture? What is one of the characteristics that makes something a mixture?
There's more than one substance.
You could
Something.
You could filter it out or distill it. Like, we could separate them by physical method.
Tell me again.
You could separate the two elements by physical method.
There you go. You can separate it based on the physical conditions. All right. So they're not chemically combined. What else did we learn? Heterogeneous mixture. What exactly is a heterogeneous mixture?
When it's not uniform throughout.
When it's not uniform throughout. Okay. So if you take a sample from the top, the middle, and the bottom, you're going to get 3 different components in each of these samples. All right. What else did we learn? Compounds, molecules, elements, atoms. What is an element?
Pure substance.
Element is a pure substance.
We cannot break it down for example, the oxygen molecule.
Ooh.
No, oxygen, just oxygen.
Okay, so you have an oxygen, the oxygen element. All right, can't break that down into anything else. It is the simplest form of matter. Very good. What's an atom?
Atom is the
Ooh.
smallest part. The smallest part.
Smallest particles. Where do you find atoms? No. Huh?
In the matter? Inside.
No, not exactly.
Found it everywhere.
No. It's one specific place that you will find an atom. Inside an element. Remember, your elements are made up of their atoms. Okay, so the element is your big little square and the little tiny things inside. Those are your atoms. All right. Now, in terms of a molecule, what's a molecule? When you have 2 atoms combined together. We have 2 types of molecules. What are they? Compound and elemental molecules. What is the difference between the 2? Ooh.
More than one.
Ooh. There you go. You must have 2 different atoms in a compound. With your element, you're going to have 2 of the same atoms. That is paramount. You must know that a compound will have 2 different, that keyword different right there, different elements in the molecule. What else did we learn? Temperature. We have how many different temperatures? 3. What is my Celsius temperature based off of?
Water.
The properties of water. What are the properties of water? What are the main 2 properties of water? The boiling point is 100 minus 2
Celsius.
There you go. The boiling point of water is 100 degrees Celsius and the freezing point is 0 degrees Celsius. My Kelvin. What is Kelvin based off of?
Yes.
The properties of gases. What is one of the main things about Kelvin? Absolute zero. What happens at absolute zero? Everything stops. All motion stops. Good. How did we go from Fahrenheit to Celsius? Yeah, what's the formula?
5 and 9.
9/5. What right here? Top Celsius plus 32. How did we go from Celsius to Fahrenheit? 5/9. Brackets. Fahrenheit minus 32. Good. From Kelvin to Celsius, what do you do?
Celsius plus
273.
Okay, so we have. So I asked for what? I asked for Celsius to Kelvin or Kelvin to Celsius? Kelvin to Celsius, what do? You have your Celsius minus 273. And your Celsius to Kelvin? Plus 273. Good. What else have we learned? Units of measurement. What are my base units? Meters, and grams. These are based off of what? What are the overall units to describe these things? Mass, volume, and length. Good. Now, from base, how do you get to kilo? Divide by 1,000. From base, how do you get to nano? A million? A billion? Billion. Okay, 9 zeros. How do you go from milli to base? Divide by 1,000. How do you go from micro to nano? Micro to nano. Multiply by 1,000. Okay? Remember, the only one that you add up to zeros is if you're coming from base. What is the unit for grams? G. What is the unit for volume? It's liters, but the how do we write this ml? There you go. It matters how you write this. It's a common M and a capital L. Always. And what was the other one? Mass. Length. What is the units for length? N? M. Right? Small m. Alright? We're going to have a whole lot of m's that's going to come towards you. Okay? So we got to keep them in order. What else? What else we learned?
Types of separation.
Types of separation. What are my types of separation? What's the first one? Filtration. What is the basis for filtration? You have the filter paper. What does the filter paper allow?
The solids, the liquids come through, the solids stay.
There you go. Your liquid is going to pass through and your solid is going to stay. What's the other one? Distillation. What is the basis for distillation? The boiling point. The differences in the boiling point. Last one? Chromatography. What is the basis for chromatography? Polarity, meaning what?
A light stays.
Like go together.
There you go. Light will dissolve light. Light go together. Okay?
Because I was almost there and then you did this and I got.
I'm gonna need us to work on our charade. Like your charades right now, it is subpar. I'm gonna need to work on that. Okay? What else? What else did we learn?
Are we just sticking to accuracy?
We didn't get there yet. Oh, properties. We have, how many types of properties do we have? 4. What are they?
Inserted.
Inserted.
It's in something.
I know it's in some physical, chemical, intensive,
What I say?
and insensitive.
It's something.
Okay. What is a physical? How do we classify physical properties? Anything that can be observed, Those are examples. I
Without
love the
changing
basic-
something, without
changing the.
changing it chemically. I guess.
There you go. Without changing the composition. Okay. Now, what is a chemical change? Chemical properties. How do we observe chemical properties? You're making something new. Okay. Intensive.
Intensive is independent, no? Or is it the other one now? It's okay.
It's independent of the amount of substance present.
There you go. It is independent of the amount of substance that's present. Extensive. Dependent on the amount of substance present. Good. What else?
We had to memorize something volume.
Wait, volume. What? You had me excited for a second there.
You gave us something to memorize, like one.
The DM reading
There we go.
square, cube.
Okay. So in terms of length, you can translate length into volume. In terms of length, how much is 1 milliliter?
1D
One
cube. Is it 1
centimeter cube.
1 centimeters cubed. How much is 1 liter?
1 decimeter cube.
1 decimeter cubed. Good. What else? Is that it?
States of matter.
States of matter. What are my states of matter and what do they mean?
Solid, liquid.
We have solid, liquid, gas, aqueous. What exactly? We're going to group 3 of them. What does solid, liquid, and gas mean? A pure substance.
That can be divided.
No.
That can be separated,
No.
broken down.
No. At.
Certain temperature.
No certain. No certain. Huh? No room temperature.
Oh, is there some, certain reactions?
No. It's specific. It's 3 letters that stand for 3 words. No.
It's a pressure, temperature, something.
This is standard temperature and pressure. These are the solid, liquid, and gas. These are pure substances at STP. All right? That matters. Now, what does aqueous mean?
That's the mixture of.
Dissolved in water. Good. What else? What else do we have? Was that it? You sure?
So we're gonna memorize the periodic table.
Guess what we gonna do? Pause for the cause. Okay. So let's see.
Pass 11.
Who's gonna be first? I'll go first. All right, Monique. For me, I would like you to give me the first 5 elements. I want you to give me their symbols, and Muhammad is going to give me their names. I can give the names.
Okay. Oh,
Okay.
but I have to say the name in order to
Well, say the name in your head.
okay. Age.
All right, Muhammad.
Is HE?
3.
Wait, hold on. It's
Batteries.
Li.
4.
B.
R.
B-I.
Really? I don't know. Sometimes you just gotta be yourself. B-E.
Wait. Wait, hold on. Let me say it in my head again.
This is so boring.
Byron. B. My bad.
Boron.
Boron. Good. Okay, let's see.
Okay, I didn't study it with the symbol. I studied these the other way.
We'll see, but you got it though. All right. Let's see. Who else? So Radha, and Bim. All right. Let's go. So we're gonna go from 10 to 6. Okay.
Also,
We're gonna flip it. All right. Flipping it.
N-E,
Fluorine,
ethyl, oh, just F,
oxygen,
O,
nitrogen.
N.
¿Qué nombre era?
10.
Well,
Why not?
6? Oh, okay, yes.
C.
There you go. Okay, let's see who else. Who else? Ronnie and who else? Who's gonna help me out?
you're gonna help me out.
All right, so we're gonna go with Rana.
Alright.
So we're gonna go now from 16 to 20. Okay? So, Rana, you're gonna give me the symbols. Ronnie's gonna give me the names. Right?
S,
Sulfur,
Cl,
chlorine,
Ag,
Ag,
Wait, that's 18.
A-R.
AR is
A-R.
Oh, Lord have mercy. Look at me. Go ahead. There you go, Argon. Okay? 19. Bananas.
N,
okay,
Bananas in pajamas. Coming down the stairs. There you go.
calcium,
There you go. So now we have from 11 to 15. Who's it gonna be? Sabrina.
I don't have any of it.
Sabrina!
I've been sick.
Okay. Let's see who else. People.
I don't want to say them. I can give you the symbol.
Okay, so we got the symbols. Tati, you gonna help me out?
Oh, okay.
Okay. All right. So 11.
You gotta say it first.
Well, I gotta see.
Batman.
Batman.
No, it's not that one.
Oh, that's not it.
No.
Let me see.
NA.
Na.
Sodium.
Sodium. 12.
MG.
Mg.
Magnesium.
13.
Yeah.
Aluminum.
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 14.
I don't know. Is it P? Oh, yes.
SI. It's not the same thing. Silicon. Alexis. S-I-L-I-C-O-N. How you pronounce it?
Silicon. And 15. Yeah, you do. Sounds like. What?
P. It's a good one. Phosphorus.
Phosphorus. There you go. We will be doing pause for the cause every single class. Okay? Alright. We ready? Questions, comments, inquiries about anything?
Yeah.
Yeah, what?
Oh my god, I started the homework. What had me stuck was, I guess what we're gonna do in the lab today.
Which
The,
one?
the significant figures.
Woo!
Oh my
Yeah.
god.
We gonna get to that in about 10-15 minutes.
Okay.
Good stuff. Okay? Now, once we start significant figures, we're never gonna stop significant figures. From now all the way up until chapter 10. Okay? Alright. So, let me get this light. Alright. Density. Density is a physical property of a substance. What exactly does density mean?
The amount of something within like volume.
Okay. Give me more.
How much is occupied the
space.
space?
Uh,
But yours be a little different.
It is different because remember, yours is more spread out. I have to compact mine.
Okay, so ours is more simple to understand, basically. What you're
Right.
saying. Okay, okay.
Okay. So we have, all right, bet. If I were to ask you to find me the density of 10 mLs of water, how would you do it? What would you do? What's the formula for density? Mass over volume. So you gotta find the mass, gotta find the volume. How would you find the mass for 10 mLs of water? What would you do?
It's 10 grams.
It'd be 10 mils.
No.
1 times 10.
No.
You put it in a little thingamajig.
You put it in a little thingamajig.
In a conversion factor.
No.
You put it in the thing,
Because
what we was
density
doing
of
last
water
time.
is 1 times the volume, which is 10.
If I tell you, I put you smack dab in the middle of the lab, and I tell you, Keith,
Yeah.
go and find me the density of 10 milliliters of water, what would you do?
You measure the thingamajig first, then put the water in and measure the
I
thingamajig again.
find Keith voice kind of light today.
Come on. Alright, so the volume of water is 10, right?
Okay.
And the density, oh, alright, so I'm in the lab.
Uh-huh.
So I'm gonna take my beaker,
Uh-huh.
I'm gonna put it on my analytical balance.
Uh-huh.
Then I'm gonna take that down, right? I'm
Uh-huh.
gonna take down that number with my significant figures over.
Uh-huh.
Then I'm gonna take the 10 milliliters of water, put it in my beaker,
Uh-huh.
and then weigh that again, then subtract to get the mass. And then I'm gonna divide that mass by 10.
But how exactly are you going to find the volume? How you?
You just said there's 10.
Yeah, but how, if I tell you,
Uh-huh.
I give you a bottle of water,
Okay.
and I tell you, from that bottle of water, find me the density of 10 mLs, how would you find that? What would you do?
Measure it, so.
Measure it how?
Graduate.
Using a graduated cylinder. Remember, these are the little steps that we got to be mindful of, okay? Once you have the mass, you have the volume, you can find the density. But now, if I ask you to find the density of my clicker, what would you do?
Water displacement.
Water displacement. Okay? What exactly is water displacement?
When you put it in the water and see how much it goes up. I think that was in homework too.
Yes. Okay? Water displacement. If you have an irregular object that you cannot easily find the volume of, you need to use water displacement in order to find the volume. Here you have a set volume in your graduated cylinder, set volume of liquid in your graduated cylinder. You then are going to place your irregular object into your graduated cylinder, and the volume level is going to rise. The difference between the final and the initial volumes, that is going to be the volume of your irregular object. Did we get that? So here we have an example. A 20 milliliter sample of liquid is placed into an empty beaker that has a mass of 31.447 grams. The beaker and the contained liquid were weighed and has a mass of 55.891 grams. Calculate the density of the liquid in grams per milliliter. Now remember our 3 questions, right? That is exactly where you start. All right, so now if we start with our first question, what's our first question? What's given? What is given? What do we have?
You have the mass.
The mass of the beaker,
You have the total.
which is what? 31.47
grams.
grams.
You have the mass, volume of the liquid. Yeah, example.
So we have the volume of the liquid, which is
20.00 milliliters.
20.00 milliliters. Anything else given?
The
Mass
mass.
The mass of the beaker and the liquid, right?
Yes.
Which is what? 55.891 891 grams. Anything else given?
That's it.
Okay, what's the second question?
What are we asked?
What are you being asked to find?
The density of the liquid.
What is it again? We want the,
Density of the.
so we want the density in grams per milliliter. Number 3. What's the number 3 question? Huh?
What's missing, no?
No, not what's missing.
What can you find?
What can you find?
Based on what is given.
Mm-hmm. So what can you find?
Mass of the
So we have the mass of your liquid. How are we finding the mass of your liquid?
Subtract.
We're going to subtract what from what?
The 31.44 from the 55.
Very good. So 55.891 grams minus 31.447
447.
grams.
24.444
24.444
grams.
grams. Can we find anything else?
Volume.
Density.
Density.
No. Before that, there's something else that we need, that we know.
The volume.
Where are we trying to find?
Maybe the volume of liquid.
We already have that was given.
We have to find use the formula.
There you go. You have to find the formula. You know the formula. So you have the density formula, which is equal to M over V. So now you have all your questions answered. Okay? So now what you're going to do is put everything together. So your density, you have your mass. Your mass is equal to 24.444 grams.
And then your volume is the 20.
Right. And divided by the given volume, which is 20.00 milliliters. So therefore my density is equal to what?
1.2222.
1.222. We're going to carry that over.
Gram per milliliter.
Very good. Grams per milliliter. That's what I got too. Okay?
You would round that off to 4, right?
To 4.
6.
Yeah, because
Why?
division.
Yes. However, we haven't gotten there yet.
Oh.
So we're going to wait to talk about significant figures in probably the next couple of slides. Okay? So, do we understand how the 3 questions work? How they pull out the information that you need in order for you to answer the question? We get it? Questions, comments, inquiries? Okay.